I have to say welcome everybody to BTS in 2020. Immediately you can see that we are in a rather special situation, and that BTS 2020 is not what it used to be during the previous years. For those of you who are here maybe for the first time, I would just like to say that this is our 13th BTS in a row, and for the last, I believe, 4 years, we've been having BTS in Biograd na Moru at this venue. Before we start, I would just like to say that due to the fact that I was in contact with a person who is infected with the coronavirus, and this is something that I found out yesterday, epidemiologists told me that I do not need to go to self-isolation. However, because we are having this event with quite a lot of people, I decided to make a test this morning. So in the morning I was in Zadar, I made a test, and I will stay in my room until the test shows that I am negative for coronavirus. So just to make things clear that I do not have to be in self-isolation, but this is something that I want to do for your safety and for your health. Having said that, I urge all of you to keep social distance between you, to make sure that you respect all the measures that have been advised by our epidemiologists. I saw a few of you on the camera not wearing face masks. Please make sure to put your masks on while you are inside the hotel. You will see that our hotel did everything that's in their power to ensure social distancing. The room that you are currently in used to hold even more than 150 people. Now there are, I believe, less than 50 chairs in that room. Also, you will see disinfectants, everything that can be used to wash your hands. So feel free to use them as often as you can. For the speakers who will be giving their talks, we also have plastic shields that will prevent you from the audience or prevent any unintentional spitting during your talk. So for the speakers, make sure you use either your masks or transparent plastic shields during your talks. I do believe that I mentioned all the things that are required, that are relevant to the coronavirus pandemic, but the most important thing is to be reasonable, keep your common sense, and not to come too close to other people. However, I am confident and I'm very optimistic that we will get through this pandemic, because if we made it through Stjepan Bogdan and his team during karaoke nights, I'm sure that we can cope also with the coronavirus pandemic. I hope you will not mind if I share a few more details with you during this presentation. You probably all already know that we have our wireless network, BTS 20. Here is the password. Feel free to use it. This network is only intended for us. Also, when the weather will be hopefully a bit nicer, you will appreciate the beauty of the 3 hotels that form the venue of BTS. This year, we are all situated in Hotel Illyria, while lectures are in Hotel Adriatic. In this slide, you will see all the all the relevant locations in the map. Let me just see if, I don't know if you can see my mouse pointer, but at the moment I'm pointing at location number 2, where all of you are currently sitting, and where all lectures and tutorials will be taking place during the event. Morning coffee breaks will be served in Lavender Bar, that is marked with number 6 in this map. In addition to that, In addition to that, demo pool that I hope you've already had the chance to visit either yesterday evening or today in the morning is here. And on Thursday and Friday, we will have some demos in this part of the venue. Our hotel where we are all accommodated and where we will be having lunch is here, number 9, and the parking lot is here. Okay, one other thing that I wanted to share with you is weather. So this is weather forecast from yesterday from 2 different sources. The first one is Norwegian weather forecast, the second one is German. But since the German one is not as good as the Norwegian one, I suggest that we concentrate on the Norwegian weather forecast that says that until the end of the week, at least until the end of Saturday, we will be having sunny weather. So I'm definitely looking forward to that. The technical program, briefly. I would just like to emphasize that somewhere before March, we had finalized the BTS program for the year 2020 with all international speakers as we usually have at BTS. Of course, due to pandemic crisis, we decided of course, after talking to our international speakers, we decided that most of these talks will be postponed for next year. So we decided this year to have more of an internal event where 2 laboratories, Robotics and Labus, joined forces to give you, I believe, an excellent program for this year's BTS, which is a little bit more compressed than it usually is. On Monday, Tuesday, and Wednesday, we will be having lectures. Altogether, 10 lectures plus 10 additional PhD presentations, making altogether 20 lectures. We will also have 6 tutorials and 1 roundtable, but more details are here in this slide where you will see that the morning before lunch is reserved for lectures, and these lectures will be streamed. That means not only streamed, but also recorded, which means that people all around the world will have the opportunity to listen to your lectures even after they are finished. On Tuesday, just before lunch, we will have a roundtable that is a part of Innova-MARE project coordinated by the Croatian Chamber of Economy. I believe that they're also here with us. I cannot see in detail from the audience, but I believe that they should have arrived already. I invite all of you to participate in this round table. After lunch, we will be having tutorials, and these tutorials, due to the nature of how they are conducted, will not be streamed and will not be recorded, but they will be here for everybody who is present in real life to attend. On Thursday morning, we will have another tutorial, and after that, until the end of Friday, we will be having demonstrations of various equipment in the pool. After each morning, somewhere in between, somewhere in the middle of the lectures before lunch, we will be having coffee break. As I mentioned, coffee break will be served in Lavender Bar. And after lunch, in between 2 tutorials, we will be having breaks where people will get the chance to walk around and get some fresh air. Coffee break is not at the same time every day. It will be somewhere around 10:45 in the duration of 15 minutes. Please do not be late, otherwise the whole schedule will be running late also. Lunch, as I mentioned, will be served in Hotel Illyria, starting around 1:15, and dinner is starts being served at 7:30. I mentioned that on Tuesday before lunch, we will be having a roundtable from Innova-MARE project. And the topics are very interesting. I do believe that all of you will find it interesting to join the roundtable. We will have some guests in real life in the room, but also some of our roundtable speakers will be online. The topics of the roundtable will involve underwater robotics and sensors, and their applications related to sea pollution and also innovation ecosystems. Regarding social events, many of you who have been here in previous years know that social events were the backbone of BTS. Unfortunately, this year we will not be able to organize social events as we did in previous years, again because of the pandemic situation and the epidemiological measures that are being advised. However, on Monday, which is today, at 8 p.m., IEEE Ocean Engineering Society University of Zagreb student chapter will be organizing a presentation and a mojito party at a location that will be defined. Their initial intention was to have this party and presentation at the swimming pool. However, depending on the weather, they will let you know in time where the party or the presentation will be taking place. Last but not least, I would like to introduce you to our committee chairs. In addition to Professor Vukic, who is the general chair of the conference, and myself, who is the program chair of the conference, I have the honor to introduce you to our two new members. Ana Golec, who is the organizing committee chair, and I'm sure that all of you know her, and Igor Kvasic, who is our new technical committee chair. A few months ago, Ivana Mikulic and Antonio Vasiljevic left University of Zagreb and moved outside Croatia. I would like to take this opportunity to once again thank them for everything they did for our previous Breaking the Surface conferences. For Ana and Igor, this is the first time that they're in the roles of organizing the technical committee chair. And just to make things even simpler, I'm not there present in person, so everything is up to Ana and Igor. So please be gentle to them during your stay here at BTS. Our program committee is, most of our program committee chairs could not be here with us in real life, except of course Fausto Ferreira, who hasn't missed a single BTS since the first one, and who I'm very happy to say will in a few days join us at the University of Zagreb at Laboratory for Underwater Systems and Technologies as a leading researcher. Other members of the program committee are listed here, and they include Ralph Bachmeier, Bridget Buxton, Bill Kirkwood, Joao Sousa, Massimo Caccia, and Irena Radic-Rossi. Last but not least, I would like to introduce you to the technical committee, which is formed of Labust members. Those are Anja Babic, Nadir Kapetanovic, Nikica Kokir, Ivan Lončar, Igor Kvasic, who is now a chair, Đulanaj, and Frane Rogic. Feel free to ask them in case you have any questions. But in case you have really important and interesting questions, of course, feel free always to contact Ana Golec and ask her whatever you need, and she will be, I'm sure, happy to help. Last but not least, I would like to mention the organizers and supporters of BTS. University of Zagreb Faculty of Electrical Engineering is organizing, and Computing is organizing the event, and it is being organized as part of a few Horizon 2020 projects, such as EU Marine Robots, Erasmus Project Impact, and I'm very happy to say that we are also, BTS this year is organized as part of AeroTwin project that is coordinated by Professor Bogdan, and this is why Larix Laboratory came here and will give us excellent presentations related to aerial robotics. In addition to that, we are supported by Interreg Innova Mare project, Hector project, where by the end of the week you will have the opportunity to see also some demos related to the Hector project, and of course, I already mentioned IEEE Oceanic Engineering Society, University of Zagreb Student Branch Chapter. Having said that, we are running 10 minutes late, but I would like to take this opportunity to announce our next speaker and our first speaker, which is Fausto Ferreira, but I will leave this honor to Stjepan, who will continue chairing the morning session. Thank you very much, and I do hope we will see each other in person in 24 hours. Bye.
Thank you, Nikola. As Nikola said, we will start with the technical session, and as you all notice, we are in a very special situation. And sadly, you won't enjoy Bohemian Rhapsody performed by Robotics like last year, but I'm sure that you will come back next year and then you will enjoy the karaoke. Even though the situation is as it is, I'm sure that we will keep a good spirit of BTS event that has been here for the last 4 years, as Nikola said. And the best way to keep this good spirit is actually to have a speaker. Nikola also mentioned this, Fausto, who is the I think the only among us that participated in all BTS events. So, ladies and gentlemen, I give you Fausto.
Thank you for the introduction. I think Jewel was also in our event. I'm here because I think the only one that is here also. It was in our events. Very easy. Well, while this gets set up, as Nikola said, I work at the NATO STO Center for Maritime Research and Experimentation, and I'll join the FER in 2 weeks, basically. But I want to show you what we do at CMRE, my personal experience, and I'll speak about competitions, which is most of the work I've done there. And then I'll speak about a bit of regulation safety for marine robotics, because that's more recent work, and I have a different background on that. Sorry? Okay, perfect. So at CMRE, we organize marine and multi-domain robotics competitions for the past 10 years. This is just my biography. I don't want to go into detail. The only thing I want to mention here is that besides my PhD in robotics, I did a bachelor in political science, and that's why I'll be speaking about regulation of marine robots. As I mentioned, we have 10 years of competitions at CMRE. I don't know if Vladi is here, but Vladi was the first one to bring competitions to CMRE in 2010, the Student Autonomous and Water Vehicle Challenge Europe. And then, since 2012, we have AUV and ASV competitions. In 2015, we did the first in the world competition with land, marine, and aerial robots. It was inspired by the Fukushima disaster. And this had a second edition in 2017, just with a different name. Before it was the Ratland, then it became European Robotics League. And in 18 and 19, we have again European Robotics League, just with land and marine robots in La Spezia. And in Seville, there was a competition for land and aerial robots. I'll go briefly through the competitions. So this was the first one. It actually was established in 2006, and it's still running every year in Europe. It's the most realistic competition in Europe for marine robotics, for underwater robotics, sorry, because it takes place in a sea basin. It went around between France and UK for the first 3 years, then we moved to CMRE in 2010. In 2014, this was the first competition. Again, it was in La Spezia. And just to give you an idea of how it is the visibility, here, this is what you can see in the water. That's why it's a very hard competition. Even if it's mostly for students, it's a very complicated competition because visibility is very low in that area. This is the kind of task that we have. So we have long-range navigation underwater. We have a mapping task. We have an inspection task, manipulation, which is the most complicated task to be solved. Then you have a combined scenario where you need to do all these missions at once. Most of the vehicles are built by the students themselves, actually. So it's not professional built commercial products, but it's good for the students to learn practical issues of marine robotics. In 2015, as I mentioned, we had the first Ratland 2015 Grand Challenge, the first competition in the world with land, marine, and aerial robots. We have a lot of supporters, institutional supporters, IEEE, both societies, Robotics Commercial Society, or Safety Engineering Society. We have all the institutional supporters from the Italian Ministry, region, etc. And this was what competition was inspired. As I mentioned, it was inspired by the 2011 Fukushima accident. The idea was to have heterogeneous multi-robot teams and to actually create a cross-fertilization between domains, between land, air, and sea. I don't need to explain what happened in Fukushima, I think everyone knows. This is just a schematic of what was the scenario. So we had three main missions happening at the same time in land, sea, and air. One was to find missing workers. This could be either outside the building, inside the building, or underwater. Another one was to survey and monitor the area, meaning mapping, basically, finding some objects of potential interest. And the third one was the manipulation, where both land robot and the water robot had to close the valve at the same time. Just to give you an idea, this was the area. It was a abandoned, actually, power plant. It was similar to Fukushima, but not as real as Fukushima, thankfully. We used also an old building. Yeah. So this old building was abandoned since the 60s. So it was a good scenario to explore indoor and outdoor. And we have a protected arbor here, 100 by 50 meters, that was protected from waves. They had a break here. So it was a good scenario for the competition. Very realistic also, only half-meter visibility, and there were several issues because of this. This is the area for marine robots. So we have two areas, one for testing, one for training. This is, as you can see, how back you can see yellow tubes. Here is the same console. Basically, the robots have to go for long range navigation also outside of the open area. And then there's several tasks inside here: manipulation, mapping, object detection, object classification, etc. Just to give you some idea of what's the area, this is the building. We did clean a bit all the grass here, but this was a semi-bottom, so it was very hard for robots. Many land robots got stuck on the sand. We even had a ramp with the wood, but still robots would get stuck. And the distance between here, basically, the starting point was here, and the building is here. This is around 150 meters. So communications were very hard. Many teams had troubles with the Wi-Fi, basically. Some teams had radio communication, so they went better. Some teams had two robots, one acting as a relay. Some teams had several tenants working around the way, so they could extend the range of communication. The building had really strong walls, very old walls, so indoor you would lose Wi-Fi and you wouldn't be able to communicate. This is what they call a machine room, where the robots would go and close the valve. And this is just some pictures of the area to show you the setup. We had a pool for testing of the robots before we went to the water. We had a platoon for easier deployments. We have some artistic pictures here. Sorry. There was some rain, so people would work a bit under the tables when they could. And as I mentioned, we had a lot of issues, especially in the first days. We had strong winds, so air robots could not fly for the first days. We had a storm, visibility in the water was practically zero. We had a half-meter visibility. We had a crash of an aerial vehicle in the sea. We had one land vehicle stuck in the sand. So we had a lot of issues. But this is an example. I mean, you probably see there's a yellow, sorry, an orange buoy here. You can barely see. That's how hard it was to detect anything in the water. We also had a lot of success. We had 150 participants from the teams, above 300 robotics experts, 1,200 visitors, and 120 articles in the media, including specialized media. We did also a kind of robotics event, moreover than just a competition, because we did talks for the general public. We had exhibitors coming, schools visiting, and the Data Robotics Challenge winners coming for them. It was their first time in Europe, actually. So here you can see the winner from KAIST in Korea, and this is the Italian team Walkman. And this was just the first time they came just before going to Iris to present their robots. So now I'll just speak a bit about ENL, the next iteration of the competition that we have. European Robotics League, it's a novel common framework that mixes several competitions in Europe. We have indoor competitions, both service and industrial robots, and we have the emergency robots competitions. And the idea was to have benchmarking between competitions. So these competitions are a bit more focused on the scientific aspect and not on the educational aspect only. And the idea is that we can actually test the performance of robots through the competitions. The missions in 2017 were similar to 15, except we had some new ones. So we have an aerial robot dropping a first aid kit next to the missing worker, and another one next to the land robot that would then bring the first aid kit to the other worker. We have another robot inspecting the debris area, and also the other robot should surface on the top of the missing worker and call an aerial robot to get a closer look and take a picture of the location. So the hardest thing here was communication between different domains from different teams. Most teams were not from the same university, so they had to prepare and make sure that everything was connected and working very well to be able to communicate between different domains. The area was the same, it's just some more pictures, but it was the same location. And these are a bunch of technical results both from 15 and 17. So again, visibility was there. This is the mannequin that you could see in the water. But 17 was managed to reconstruct very nicely the mannequin. As I mentioned before, some teams would bring antennas that would drop along the way to extend their Wi-Fi range, and this was a winning approach, I would say. And this, you'll see better in the next slide, but in detail, it's a fused map between ground and aerial vehicles. So on the top, you can see the ground and aerial maps, basically, and this is the fusion result produced. Teams had 2 hours to deliver the results, so this was made in 2 hours. And these were 2 different teams working in the same consortium. So it's quite impressive what they managed to accomplish. This is an excellent underwater map. Maybe you cannot see it perfectly, but here you can see all the objects that we have underwater. Basically, buoys here, another 2 buoys here. This is one structure. This here is the debris, and this is the other structure on this side. So this is a very impressive sonar map from the team Tom Kyle, if I'm not mistaken. This is another reconstruction from the building, this time with texture. And again, it was, for the time that they had to produce these results, it was pretty good. In 2017, we had also robotics events similar to before, with a lot of talks, exhibitors, exhibitions of demos, I mean, and workshops for children. So in 2017, we established a leading competition in Europe for emergency. We had 17 different teams that formed 7 main teams. We also had industry helping us with the judging. For instance, University of Newcastle provided a tracking system for underwater vehicles. And we had Texas Instruments, IEEE, also end users, so we tried to involve all possible stakeholders. The thing that is missing maybe for the future is having competitions as part of the curriculum in universities. We have many students doing master thesis to the competition, but it's not yet on the curriculum of any course in the university. We have many success stories along the years. One team that started as a student team has now a spin-off and is selling their vehicles, University of Girona. We have many students that now are in leading companies of the field, doing CBITES, NOC, CMRE itself. Many companies giving awards or actually components to the teams, and even teams that had zero experience of marine robotics that joined in robotics because of this competition. So just the last 2 years, we moved back to La Spezia. It's a smaller environment, and we didn't have the aerial robots. It was just land and sea robots, again in collaboration, but it was a bit simpler in that sense, and was easier setup to deal with. The challenge was similar. In this case, it was an accident in a port. So we had, again, new tasks. We added removing rubble from a missing worker. So there was some rocks on top of the mannequin, and the robot would need to manipulate and take off these rocks. It also had to bring a canister with water to a fire location. So we always try to push a bit further the state of the art without making sure, or making sure that teams still are able to accomplish something. Some results from Australia. Here is RC basin and the sonar map, again, two structures that is obvious on the pictures. And this is the indoor mapping of a building. Another sonar map from the team Pascoal. Here you also see very well the two structures. There's a lot of multi-path effects because it's very shallow water, it's 5 meters deep maximum, and you have the wall around. So it's not an easy environment. Visibility is a bit better than in Gambino, but still it's not the best. The future is the Matrix project, and this project is even more on the methodological aspects and the benchmarking aspects. We will soon, early next year, probably launch a virtual competition, and then we will have physical competitions, Corona allowing, in next July and then every year again. But the idea is that we attract also AI community, so we'll have virtual competitions and then physical competition every year. And we'll use real data to test and to train teams in the virtual competition. As I mentioned on the outset of the presentation, benchmarking is one aspect that is needed to test the performance of robots and to introduce them to the market. The other aspect is regulation. So I'll go through some slides regarding regulation, and this was also based on my background in political science. I won't go too deep on the legal aspects, so I don't bore you to that. Let's see. Here. So,
full screen. Yeah. And also, can you try to talk more directly to the microphone because people online have trouble.
Oh, okay, sorry. I'll try to do it. So, I mean, I don't need to explain how ASVs are now widespread. The point to focus is that now we have autonomous ships, or there's a lot of money being invested in autonomous ships, big autonomous ships, not research small ASVs. The International Maritime Organization started recently a working group on these kind of vessels, and there will be many, many projects in the last years. We have a test area for autonomous ships in Norway, we have the autonomous ferries in Finland, if I'm not mistaken. Japan is planning to have self-piloting ships by 2025. There has been a lot of projects on ships. But there's a question of how do we classify these ships, how do we register these ships, how to avoid collisions, which rules should we apply? Do the rules that apply for normal ships can apply to unmanned ships, or do we need new rules? Do these rules should be different depending on the type of sea? And then who is liable? I won't touch this aspect because it's a bit technical on the legal aspects. Recently, we had an ASV registered as a ship actually in the UK, and many authors highlight the need either for adapted or new rules for unmanned ships. Others say that maybe what we have already now, the UN Convention on the Law of the Sea, could apply. The same for the international regulations for preventing collisions at sea, COLREX. But it's a bit hard to get consensus because there's no definition of ship on the UN law. Similar, the COLREX say that watercrafts should be used as means of transportation. So if you think about the small ASV, it doesn't transport anything except its sensors, but its function is navigation. It's not transporting sensors from one point to another. So it's hard to understand, does this treaty apply or not? There's many groups working on complying with this treaty for the safety of their ASVs, for avoiding collisions. But there's no mandatory rules yet. There's been many work groups in Europe, UK, IMO, US, South Korea, but it's still not clear. In AUV regulations, state of the art is even a bit farther from ready, let's say. There's no specific regulations, international approved for AUVs. There's no authority for AUV operations. Normally, as a AUV operator, you deal with the coastal authority, with your state authority, but there's no harmonized international framework. And the legal status is unclear with respect to UN Convention of Law at Sea. So we have collision avoidance for AUVs, of course, but we don't have regulations for collision avoidance. There's no ranks equivalent for underwater. And of course, it's hard to implement because of 3D space and perception issues. So what we are now starting to do is to propose a way of having collision avoidance underwater for AUVs and for the interaction with the ASVs and other manned vessels. The idea is to use Janus, an acoustic communication standard, to communicate your position and make sure that the other AUV knows where you are and avoids colliding with you. So perhaps you know about AES, Automatic Identification System, which is mandatory for all vessels and ships. We had a version of underwater AES implemented with the Janus, and it is used in the past to give submarines a picture of vessels in the area. This has land, long, heading, speed, status, and an identifier. In respect to the original AES, with the Janus AES service, we have the depth and type of vehicle. This is kind of a message I will go into detail, but basically, they said you have an identifier, type of vessel, latitude, longitude, depth, speed, heading, the status. This is basically what you have in AES, and then you can have more than one vessel in one message only. So our idea is that underwater vehicles that are surfacing can passively listen to what's happening at the surface. If the surface ones are either broadcasting with the acoustic modem, or if there's a buoy broadcasting their positions, and then they can avoid a collision while surfacing. Similar, when there's a lighthouse or an oil and gas platform, if these structures send their position, robots can avoid colliding with a fixed platform. It's now that AUVs and ASVs have acoustic modems. For manned vessels, it's not so common, but they could be installed. Or they could have gateway buoys that broadcast the position of sea vessels, for the surface vessels, to the underwater ones. We had some at sea testing. This is a general scenario with 2 AUVs, a ship, and a gateway buoy. You have the surface ships transmitting with radio to the buoy, and then here you have acoustic communications. There was extensive testing since 2015. Initially, as I said, just for submarines, but still, the important thing is that we got up to 6 kilometers range for this sound pressure level. Then later, we added the AUVs and the ASVs, and the range increased up to 7.5 kilometers in ramp 18. This has work done with the Roberto Petroccia, which is visiting just next to me, and João also from CMRE. So, to conclude, the point is we need better regulation for ASVs and AOVs. The fact that we have now many ships has brought a lot of attention to this issue at the surface level, but underwater there's very few efforts. There's no authority and there's no collision avoidance regulations for AOVs. Of course, these are hard to implement due to the environment, but we hope that this initial work will help to have underwater collision avoidance regulations. And I think I'm out of time. I have videos late, so I don't want to make this later.
10 more minutes.
Oh, really?
Yeah.
Okay. I thought you wanted to catch up. Okay. Okay. I mean, this is the last slide anyway. Janus is a standard that we can use to provide underwater AES service. It's a possible way of implementing underwater call rigs, and at the same time, we can also use it for better localization, planning, and emergency response. The idea is if all vehicles, including manned vehicles, have acoustic modems, you don't need any more human in the loop for collision avoidance, because everyone will be able to know where everyone is and will be able to change their course automatically by knowing where is a possible collision. Of course, there's a big problem, which is the loss of communications underwater. So whenever we identify some rules, you need to think about this issue and how you deal with loss of communications, what happens in those cases, how can you still be safe or not. I have a bit more preliminary work on these aspects. We have some figures, let's see. Okay, so this is the same scenario. I just want to show you this part. So basically, this is more advanced message of AES. So if you think about underwater, you won't be able to communicate all the time or use a lot of bandwidth, right? So the idea is that in one message you send the most information possible, so you save sending a lot of messages. The idea is, what kind of information are you interested in underwater? You're interested in the position of the vehicle, size, type, what's his route, maybe his area of operation, his maneuverability, and his autonomous level. So when you apply this to the known domain, we have categories: 3D position and accuracy of position, size classes based on the length and weight, type classes the same as we had before, speed and course over ground, autonomy classes based on vehicle type, if it's an ROV, an AOV, or an ASV, and then how maneuverable is that vehicle, what's his bounding box, basically its operation area, what's his mission type, if he's going zigzag, random search, or long moor, and what's his next waypoint, position and heading. If one vessel transmits all this information to another, they can not only prevent a collision next to each other, but a long-term collision avoidance, because there's also the bounding box at the next waypoint. So not only are you preventing a collision in a minute, you're preventing collision for the whole mission time. That's the idea. So with that, and with the Janus, we extended the AES method I presented before, and we calculated how much or how fast you need to repeat this message if you want to avoid a collision. So these figures of merit here are for the case of low power transmitter in the 2 kilometers range, fixed asset like a lighthouse or an oil and gas platform, and a moving vessel. And we have 4 curves for 4 different vehicles at different speeds. So we have a small vehicle at 1 knot, large vehicle 8 knots, then up to very large vehicle at 20 knots. These vessels need different safety boxes, 50 meters, 200, 400, 1,000 meters. And depending on how fast you're going, how big is your bounding box, you need the lighthouse to send a message more times or not. So if you're in a small vehicle, the lighthouse can send a message only every 3,700 seconds. Because even if you lose the first message, you have time to actually prevent a collision before you get to the lighthouse. Instead, if you are a large submarine at 20 knots, the lighthouse should transmit the message every 90 seconds. And this is if there's no packet lost. If there's a packet error of 75%, then the lighthouse should transmit the message every 20 seconds, which is a lot and requires a lot of power. So this was just to evaluate feasibility. And now the idea is estimates maybe should we send less information from this, so you have a shorter message, so you use less bits, you use less power, and you can send the message takes less to arrive, and you can send with longer periods of time. This is still under discussion, but the idea was just to estimate how fast you need to send messages if you want to avoid collisions with a fixed asset, basically. I think I've run my time now this time. And I'm happy to answer any questions. I'm sorry I was stressed, but I thought you ought to catch up with the schedule.
Thank you, so we have time for 2 questions. Okay, I'll raise the eyes. If you can shed more light on metrics. You mentioned metrics as a new program. Yes. Is this program funded by European Commission or by companies? Just a few more.
Sure. It's a European Commission project, Horizon 2020, and we have actually, I had a slide about it. We have 4 areas of of competitions. We have the emergency one, we have agriculture, healthcare, and industrial settings also. And the idea that all these 4 areas will have the same methodologic evaluation, and all of them will have 3 virtual competitions and 3 physical competitions. The idea is to attract more people using the virtual competitions. The idea is to attract more people using the virtual competitions and to use real data sets to train for the future competition. Because one thing we notice is that teams are many times not ready because they don't have access to good data. So the idea is every year we do physical competition, get data, do a virtual one after, and with this we should improve state of the art. That's it.
And you are starting next year?
Yes, the process started this year, but we have the first physical competition early next year. Okay. And we should have a physical one in July next year. You'll know about the call for sure.
Thank you. It doesn't work. Okay, any other question?
Yes.
Regulations, except for defining how to communicate, do you plan to include some kind of traffic rules or some kind of collision avoidance rules?
Yes. We started with that, but it's still ongoing. Sure. We started looking at that. This one is on? Okay, now it's on. We started with that. The idea is to look at the actual corex for the surface and see if they apply underwater or not. Of course, some won't apply. All this based on vision won't apply. You need to adapt for underwater, but many people say when a submarine or an AUV comes to the surface, it will respect the normal corex. So if in the surface you should turn left, while in the underwater you should turn right. So the idea is that you will use as most as possible on the underwater what is at the surface. Basically.
Similar rules?
Yeah, similar rules, yes.
Okay. Thank you, host of the report. Okay. Our next talk is related to underwater communication networks, and it will be given by 2 lecturers. Professor Antonio Pascoal from the University of Lisbon is one of the lecturers. Usual guest here at the Breaking the Surface. Unfortunately, this year he was not able to come, so lecture will be given online. And the second lecturer is Roberto Petroccia, who is a research scientist at the NATO Center La Spezia. Professor Pascoal, Roberto, the floor is yours.
Okay, I don't know. Good morning. Good morning. It's a pleasure to be here. So, Roberto, you are already sharing, right?
Yeah. Can you confirm if you see the screen that I'm sharing?
Yeah, I see everything. Yeah.
Okay. Good. Good morning, everyone.
So please go ahead if you want to do the introduction or.
Well, first of all, can you confirm you can hear us from the audience, just to make sure that we don't spend time talking just to ourselves. So it's okay. Okay, good. So well, Antonio, I will leave the introduction to you.
Yeah.
You are way more experienced than myself, and then I'll jump in later on.
Okay. All right. Good morning. It's a pleasure to be here. Let me just close the door. Just 1 second. Okay. So it's good to see old friends, even if it is only on the screen, but it's a pleasure. So times will get better, and I hope we'll be able to be again together very soon. So Roberto and I will be giving this lecture on hybrid acoustic-optical underwater communication networks. And this is in the scope of a European project. Roberto, the next one, please. Yeah. Can you, the next slide?
I'm on slides number 2 with the key objectives. Can you see it?
No, it didn't change here.
Okay, let's see if we go over technical issues here.
No, that's okay. Okay, now if you...
So you still see the first one or the second one?
I see the first one, and probably everyone is seeing the first one.
Okay, let's see if I...
But it's showing it correctly, so probably if you just advance this... Yeah.
Roberto, I think that we are sharing from the screen. We all see your PowerPoint work, but not the other. So maybe if you share the other screen.
Well, trying. I only have one screen.
Now it's there.
So let's see if we do like this. I probably is not the... Let's see if we can manage this way, because I don't know what's going bad with the screens.
Roberto, if you just share the PowerPoint, not the slideshow.
Yeah, well, I'm trying to do that because I don't have any other screen and no notes from the speaker. So it should go in the... What do you see now?
I see the objectives, but somehow the slide is cut. I don't know if you guys also see the slide being cut.
Oh,
I can try do it myself.
Yeah, let's see if it's an issue with my computer, or if you try to share on your side, Antonio.
Let me see. So I'm not used to the... I think I have to click open share. Oh dear. So open. Close share tray. I open share tray. We need permission. Go to set. Oh dear. Screen recordings. It's asking me for a lot of stuff. I don't know. Oh man, this is bad. Accessibility, screen recording. Yes, I'm allowing this.
Do you see better now? Because I try to change the screen. Do you see anything changing now?
Yeah, the slides are a bit cut, but I think they are okay overall.
What from the audience? Can you see? I mean, now going to the next slide just to make sure that you see all. Do you see the lecture organization, Antonio?
No.
Okay, so
Roberto, we do not see the presentation view. We see the view from your Riproduci, or in the bottom left.
Yeah.
Yes, that. So when you click it, it does not move to the presentation. It remains in your PowerPoint window.
I don't know how to fix this, honestly. That's
okay,
why.
open.
Let's see if Antonio can make the miracle there, or we will MacGyver it.
Roberto, how many presentations you have open?
Only one.
Only one. Okay, can you stop sharing the screen and then share desktop? So when you click on the share screen, there is a desktop. So just share a desktop. It's the most leftmost on your computer when you click this rectangular.
Okay.
Yeah, that's it. Now click presentation.
Yeah.
So the first slide is EU, okay, lecture organization. Yeah, that's it. Okay.
So, well, thanks a lot for the support.
No problem.
I thought I was an IT guy. I just need to change my resume for next application.
Okay, you just lost your 5 minutes for a question.
Okay, we will make it fast. Okay.
Okay, so good morning. So this work is being done in the scope of the UMR project, and the objective is development of advanced marine robotic systems and technologies. And in the process, we are affording end users access to existing infrastructures. And of course, the University of Zagreb is part of this network. As you can see, there are many, many, many participants. So, okay, Roberto, the next one, please. So the lecture organization, will start with some examples that motivate the question, why hybrid optical acoustic communication systems? Then we'll get into the so-called cognitive communication architecture of CMRE. Very briefly, I will mention the optical modems that now have become part of this architecture. First integrate. I don't see the slides again. So first integration in validation trials at CMRE and IST, and then future work and new challenges. So the next one, please. Okay, so why should we be concerned about underwater networking? So as you know, there's an increasing number of assets being deployed in the water. More complex tasks have to be performed. There's the possibility to cover large areas with multi-hub communications, maximize system performance when conducting missions, and using robots to accomplish missions and take human operators out of the risk. So the next one, I should have a series of slides that I will describe very briefly. An example of a project where we require the use of underwater communication networks, MORPH. So MORPH, a bunch of vehicles to do marine habitat mapping of structures along vertical walls. So we have 1, 2, 3, 4, 5 vehicles. And here it's very important to do these surveys near the coast, to have them talk to each other to do cooperative navigation controls. All right, next, please. These are very quick examples. Another interesting example is WeMust for seismic surveying, where we had 2 catamarans at the surface with the acoustic sources, and then 4 vehicles underwater pulling hydrophones, these are called the streamers, to do seismic surveying. And again, it's an orchestra underwater, and they have to talk to each other and to do some form of networking. Okay. This is a very interesting, this is a project, it's an initiative at this point. We don't know if it was approved or not, where we extend the WeMust, and now on top of having surface vehicles and the common vehicles pulling the streamers, we also have vehicles that specialize on detecting magnetic anomalies and using vision. So again, it's a big orchestra underwater, and in order to make them work correctly, you have to do proper networking and then cooperative navigation and controls, okay? This is an interesting initiative as well. It's for tracking, detection, tracking, and assessment of the spatial extent of microplastics. It's a bit strange because you have surface vehicles, underwater vehicles connected by these streamers with hydrophones, and all of them are emitting, and they are all receivers, so it works like acoustic tomography. And then they have to do some spatial maneuvering in order to find out what the size of the blob is. So again, it's a very interesting example of networking, okay? So finally, and this is a project that was approved a couple of days ago. It's a FET PROACT initiative. It's a very interesting project, radioactive monitoring in ocean ecosystems. It's being coordinated by an institute in Greece. And again, it's the use of gliders, underwater gliders and surface gliders, in order to enhance the capability of detecting radioactive sources. They could be natural, they could be artificial. So again, networking is the keystone, it's the underlying technology required, okay? And finally, this is a subject that is very dear to our folks in Zagreb. the cooperation between humans and robots, I hope one day we'll come back to this process where you have the cooperation of, like I said, humans and robots, and you need networking, of course. All right? Yeah, next. Oops.
Okay.
Okay, so Roberto, please, you can.
Take it from here. Sorry again for all the technical issues, but so after these those very interesting use cases presented by Antonio, I think it's fair to say that I mean, in order to have all those devices cooperating, we need to have them able to share data, so communicate. If we look at the possible ways to share data in a wireless way underwater, we have acoustic, radio frequency, and optical comms. And in this graph here, we have on the x-axis the communication range from centimeters to tens of kilometers, and on the y-axis the data rate. So we can see that, and all of you, I'm pretty sure you are familiar with that. Acoustic is the more mature technology, what is used so far, and is the only one that is able to cover long communication ranges. However, the bit rate is very much reduced if you compare that with the RF and the optical case. Optical comms are becoming more and more, are gaining more and more traction. It's not yet an established technology. It can allow to communicate over tens of meters at high bit rate. And then there is also RF, where very short comms, but they can also be applied underwater, for example, for docking with high bit rate. So all of those have their pros and cons. If we look, what are the challenges of underwater communication? Well, as I mentioned before, limited bandwidth in terms of data rate, and you have a very dynamic environment with the slow speed of propagation that varies in time and space, 5 order of magnitude lower with respect to what we are using in the terrestrial domain, so speed of light. And we have Doppler, whole bunch of spreading loss due to the bounces on the surface or on the bottom, scattering. Everything is dependent in terms of frequency, band, range, ambient noise, shadow zone. So the communicating acoustically underwater is what we typically do, but is very, very challenging. It's very dynamic environment. If we look at the optical and radio, as I mentioned, they are not established technology. For optical comms, short range up to 10 meters, radio comms, centimeters. For optical comms, you typically require line of sight, so it's not very good for point-to-point comms. In a network scenario where you need to share data with all your neighbors, so for broadcast transmission, but it's mainly for point-to-point. And then it's very sensitive to particles, bubble, turbidity that can be very much affecting the quality of the comms. Radio. Well, the big issue here is the communication range, very short. You can also try to increase that to a few meters, but then the big challenge is the size of the antenna. So I remember that there was some case where they were adding RF on AUVs, where basically you have the antenna going all around the AUV just to reach few meters and be able to share data underwater. So,
Roberto, can I interrupt just for a second? Antonio, could you please mute your microphone? Antonio.
Yes.
Okay, Antonio, it was you typing like crazy in the background.
Yeah, okay, go on.
Sorry about that.
Thank you. So if we want to look how we can improve comms in the underwater domain, first of all, if we have different way to communicate, we should take advantage of all of those. As I mentioned, they have pros, but they have also cons. So general idea here is and is better than or. I would like to have acoustic and optical and radio rather than only one of those. And we need also to push a lot on the cooperation among the heterogeneous nodes, surface and below the surface, because in many cases, if those devices are able to cooperate and then change, for example, the topology of the network, you can already improve the communication and accomplish the mission. The last but not the least, there are a lot of services that are required by your underwater network. If you have vehicles, they need to localize themselves for the monitoring part. They need to be able to navigate. They need to be able to communicate. Instead of tackling all those services in an independent way, which may be less effective, we should try to combine those. So basically, combine the communication together with the navigation, localization, and cooperation. Now, if we focus on the first item here, like the integration of different communication means, which is also the topic of this talk, we had to say, so what do we want to have out of a hybrid communication system? So we would like to have the ability to adapt in real time to select what is the best communication mean to select or the best configuration. And we would like also to limit the resource consumption, because every communication over a particular technology may introduce, may consume resources. So for sure, in order to accomplish this task, if we take something that is an architecture that is very rigid, monolithic, this will not give us the level of flexibility we would like to have. And in terms of limiting the resources, we cannot be as naive as, okay, I have a bunch of different interfaces for communication, just transmit on all of them, and eventually the message will get to the other end, because this will be very, I mean, not an optimized approach. So we need to have something that is flexible and give us the possibility to adapt. And this adaptation goes very much in line with something that is very popular in the radio domain. So software-defined radio. We want to have software-defined solution also for the underwater domain, where we don't limit ourselves only to the physical layer, so which is typically done in the radio domain, the possibility to adapt and select the communication technology, but we need also to go up in the communication stack and then select the best solution to apply depending on also the technology that we are using to communicate. So we need to reserve the communication medium, because it's shared by all the nodes. We need to understand how to route messages, how to do our encoding, security, compression, and all these will strictly depend also on what kind of technology we are using to share data. If we have a very limited bandwidth and we need to transmit a lot of data, probably we need to do a different level of compression. If the channel is very unstable, and then we want to do any channel reservation or routing where you need a lot of back and forth, so requests and replies, probably that's not the best way, because you may lose a lot of messages and waste the limited resources that you have. So all this software-defined approach basically need to span from the physical layer up to the application, which is something that is not done in the radio domain. And we need to strictly combine this with all the networking capability and adapt the topology that I mentioned before. So we need to go toward software-defined solutions. And in order to, let's say, to overcome this challenge, you have a bunch of different. This is something that is getting very popular in the literature. Here I'm presenting the solution that we have been developing at CMRE, what is called our cognitive communication architecture, the CCA. So the idea is to have something that still keeps the layer structure of the traditional OSI communication stack, which is very good in terms to have a modular approach. But different from that, at each layer of the stack, we have a large set of solutions, of heterogeneous solutions, what we call our protocol modules, and then we have what is called the policy engine. So basically the brain that decides what to do. And in order to have that level of cooperation from the physical layer up to the application, we need to have very extended cross-layer messaging. So all the different layers, all the different models need to be able to work together to be very effective in optimize the communication. So just to go a bit more into the details. So as I said, we have different solutions at each layer and the policy engine, which is the brain. So based on the feedback that you get out of the physical layer on the reliability of the communication channel, or also depending on the mission that you need to perform and the quality of service which is required, the policy engine need to select what protocol module to use or what sets of protocol module, because you can also use more than one. And then all the message propagate down the stack. Eventually, you have more than one here, and then can reach the physical layer where the policy engine at the level can select, okay, this message is going to be transmitted acoustically. This one is for optical only, or a combination of those. And we use this structure where the policy engine is basically controlling all the data that are arriving and leaving that specific layer. And this allows you to have a very enhanced way to adapt and to interact with the protocol module, allowing the developers to have both very smart protocol modules and a more simple policy engine, or the other way around. So we have developed this CCA, and since 2016, we have been deploying our communication architecture on a bunch of different assets, embedded devices, most for surface, underwater, and also system installed on board of submarine for our experimentation. And this has been proven to be a reliable and effective way to improve or to ensure comms. In terms of resources of CPU and memory resources is very limited. So on embedded platform, we had about 1% of CPU and the memory with very limited delays when transmitting and decoding messages. So we decide within the UMRIN project to use the CCA to basically foster the development toward those hybrid acoustic-optical systems. And what we did in UMRIN, specifically together with the group of Antonio, we integrate the Blu-ray optical modem developed by the AST group as one of the physical layer, physical solution of the CCA. So to have basically optical comms, in the CCA we also support acoustic comms with the commercial off-the-shelf modems, or Genus, that was also introduced before by Fausto, and radio comms. So we have heterogeneous and different way to share data below the sea surface. If we look at the Blu-ray optical model, the main driver behind this design was to have something which is low cost. So if we look at the cost, the cost of material is about 300 euros, and to have also something that is very robust to the background light. So to work effectively also close to the sea surface. This, of course, came to the price of reduced range, and for Model 1, the bit rate was also a bit on the low side, 20 kilobits per second. But we are very eager now to start using Model 2, which should be able to go one order or more of magnitude, so increase in the data rate. And this will be also part of the work within UMRIN. So for in terms to validate the integration, we conducted few tests in the harbor. So in the same area that was mentioned by Fausto in the previous slide. So what we call the Loon area, where we have our testbed deployed there. And from the pier, we attach two modems to two poles and start basically increasing the distance. The modem were attached on those fixed structure, and we were mainly interested in evaluating the communication range. We didn't do tests about the angle for the line of sight for to have communication between the modems. The depth of the modem was about 1.7 meters below the sea surface, so very close to the surface, and the days were very sunny, so a lot of background light. Visibility was about 4.5 meters, and we used the Secchi disk method. And we also use different configuration for the modems, for the optical modem. So basically, if you change the place where the photodiode is placed, you can, on the one hand, increase the aperture angle, but on the other hand, you reduce the optical gain. So basically, we use the modem in two different configurations to see how the angle with respect to range affects the communication. and we transmitted thousands of messages using this CCA integrated with the modem. Here are some of the results. So we basically move from a distance of 2 meters up to 10 meters. Modem 1 was the one with the photodiode close to the focal point, which means reduced angle and a higher gain. And in fact, here we can see that for the two modems, so basically the communication was bidirectional. Modem 1 was transmitted to modem 2 was transmitted then to modem 1. You see that up to 7.5 meters, both modems were able to have 98, 97% of the correctly received 97, 98% of the messages. But then the one with higher angle and reduced gain, modem 2, after that immediately start dropping all the messages. So basically not being able to receive more messages, while modem 1 up to 9 meters still have more than 90% of the received packet, which is also in line with the specs for the modem. So typically you have that kind of communication range. Another important thing to notice here is that the communication dropped very rapidly. So in the sense that it's not that you start seeing a degradation in performance. You move from 0 to 0 here, basically. And this is also very important. Whenever you need to adopt this kind of communication, you need to keep that into account. Next step within the UMarine initiative is, okay, now we have a communication architecture that supports acoustic-optical, but now we need to have that, introduce the smart solution that will allow the system to adapt and to basically select which solution to use, or in some cases even both, but trying to push on increasing the reliability of the communication while reducing the resources that are somehow wasted, so that are not useful for the exchange of data. So since we have acoustic that is very good in long range, optical for short range, a natural approach here is basically use the distance between the assets as a way to decide if you want to go long range or short range. And you should also be able to, if you need to transmit a large bulk of data, which is not feasible through acoustic comms, you need also to be able to store messages, not try to push everything out if there is no one else there which is able to receive the information. So something like delay tolerance approach similar to the delay tolerant network. So what we developed a solution here in the CCA to basically enable or disable the optical link on demand. So when you are in proximity of a node to basically offload data in a fast way, you enable the optical link. Otherwise, you continue using acoustic communication for your navigation communication. Try to get in proximity of the nodes for offloading data. So basically, something is called data mule. So that is known as the data muling strategy. So our CCA solution makes use of some control message to verify the presence of the optical link. And if the optical link is there, that line of communication is enabled and you can offload the data. We also try, as I mentioned before, to combine basically all the different services in the stack. And so most likely your AUV will need to estimate some range. We will need to collect some range measurement for the navigation. So this can be used to optimize the procedure to check if a link is there. So basically combining acoustic ranging with the enabling and disabling of the optical link. So we developed the solution and we run a simulation study to validate what was proposed. Our scenario it is a very preliminary work. And so we started with a very simple scenario with basically one AUV that is monitoring an area, collecting data, and then need to offload the data to a surface station that needs then to relay the information to the operator. Mission duration for about 1 hour. So the both systems were equipped with the acoustic modem and optical modem. For the optical modem, we use some specs along the line of the Blu-ray Model 1, the one we have been using so far. While for acoustic comms, we use something similar to Evologics, more medium frequency modems, which is what we have installed on the Loon. So the idea is to have a simulation scenario similar to what we would experiment during UMRE. Both nodes produce telemetry and control data, so short messages every now and then to see that they are alive and to report about their status. And the AUV is basically collecting sensor data with a payload of every sensor message is of about 100 bytes, so not even feasible to be transmitted in a single shot through the acoustic modem, with different generation rate. We were interested in evaluating the scenario where basically a fast generation rate or a slow generation rate. So 0.1 packet per second, so it means 1 packet every 10 seconds, or 1 packet every 2 seconds for the 0.5 case. And we also consider different mobility for the AUV. So it's moving at 1 knot or 2 knots in straight line of about 100 meters, crossing the position of the surface node. So basically the task of the AUV is to, while moving, be able to detect when he's approaching the surface node to enable the optical link and start the transmitting data. So the two configurations that we consider here is one where basically we don't combine ranging together with the enabling of the optical link. So the node is configured to check every 10 seconds if the optical link is there. And the second one, where instead, so the adaptive assembly, where instead you don't have a fixed structure to sample the link, but you base that on the ranging information. So in the table here, you can see the non-adaptive assembly, so with the fixed, basically without combine that with the ranging and combine that with ranging, and the scenario where you have a slower motion with the 2 generation rate and a faster motion with the 2 generation rate. In terms of packet delivery ratio, what you see in the first column here, both solutions are able to give quite good performance. But if we combine the sampling of the optical link together with the ranging measurement collected acoustically, we can reduce the overage. So the number of control messages that are transmitted, which translate into the amount of energy which is consumed by the AUV. And also, being adaptive, we can slightly increase the packet delivery ratio. So long story short, having a more adaptive approach seems a more promising solution. And on top of that, this will also give us the possibility to be more flexible, because in this very simple scenario where you have the vehicle doing straight lines and approaching the surface node, even the packet delivery ratio is similar, and you have this kind of gain in the resource consumption. But if you have a bunch of different nodes in a more complex configuration where the node can disappear for half an hour before before approaching your surface station or your collection point to offload the data, the overhead you would increase without an adaptive sampling would be way higher, and your packet delivery ratio could be way lower. So out of our initial simulation study, this seems to be a promising solution. And next step will be something we are already working together with the IST team to integrate this full solution with the control software of their AUVs. And the plan is to have a C-test as soon as the COVID situation is over and we will be allowed to travel. So the idea is to have in-field tests both in Lisbon and at CMRE using the Loon, and have this full system with AUVs, static nodes, acoustic comms, optical comms, and validate what we have been developing and testing so far. And now we go toward the last few slides about the future, and I will leave again the floor to Antonio. Since he made the introduction, I give you the honor to close the to close the lecture.
Thank you very much, Roberto. So I see that more and more we'll see or witness the use of hybrid communication networks, mostly acoustic and optical. Of course, there's also electromagnetic. Optical modems, they scare away some people because of the visibility of the water and therefore possibly the short distance. But they are becoming very important, for example, for communication between vehicles and benthic stations that stay on the seafloor and acquire data, and now and then you have a vehicle coming up, hovering at very close range and uploading the data. Or communications between vehicles and stations installed on offshore infrastructures. And probably one of the most exciting things is when you have formations of underwater vehicles at close range, let's say 3-4 meters, as the example I gave you on seismic surveying, have the optical solution. Oh my, just a second. Sorry about this. So have the optical units not only do the communications, but also do relative positioning. This would be a dream. It's a very interesting proposition. I'll give, oh, so sorry, Roberto, the next one, please. I'll give you a few examples. This is a project that is being running here in Portugal called Ocean Tech, and essentially it's to develop the hybrid ROV AUV that is deployed from a ship, then locks onto a station that is connected to one of these pillars of an offshore structure. And once it docks somehow, then it releases an umbilical, goes about doing a survey, and then comes back and then becomes an AUV again. The communications here are done optically at very close range between this station and the infrastructure, and then goes back to shore. So it's a very interesting application. I have shown this video before, I'm not going to show it, where we have communications, optical communications between two vehicles underwater, but we were cheating because we had the mast sticking out. So during the first step, they were doing the locking using aerial communications, and when they found out that they were locked, then they would switch to optical. So here the problem of directionality is very compelling. By the way, this is a very nice connection between communications and cooperative control, because if you have a bunch of vehicles and you try to communicate with each other at short range, then you have to point the beams in the appropriate directions. Of course, you can have steerable modems or beams. We are building one now, but still you need to have a vehicle running sort of an estimator where it thinks the other vehicle is in order to point in this direction. So it's very interesting because it's this intertwining of network cooperative control and optical communications. And then of course underwater, it's the area par excellence to combine acoustic and optical. So there's a lot of work that should be done along these lines. Okay, Roberto? So at this point, we'd like to thank all the people at IST and in Italy, CMRE, that have contributed to this project. There are many. We are very, very thankful for all these colleagues of ours that contributed to different parts of the systems that we are testing. Okay, so Roberto. Now, thank you. If you have some questions, please go ahead.
Okay, thank you very much. Well, we have some time for 2 questions before we go for a coffee break. Okay, just a second.
So I have a question about the optical communication. What sort of light did you use for it in terms of wavelength?
I'm not familiar with all the details, but I believe it's green. You asked about the type of light that we use, right?
In terms of your test, when you test what the range of the actual model was underwater, because the population of lower wavelengths is much
Yeah,
lower.
I'll give you examples. In very clean water, like in a pool, for example, we managed to go up to 15 meters. But these are very ideal conditions. When we went in the harbor here, we're using the Secchi disk method. We estimated the visibility to be 2 meters, then typically we could go twice the length, so 4 meters. So it all depends on the visibility. If we operate in the Atlantic, in the Azores, where the water is very clean, then I would expect to have a visibility of 6 to 7 meters with these modems, because the power is not extremely high. If you are in very turbid waters, then you have a problem.
Okay, and then why did you choose this color? Why did you choose that wavelength as opposed to maybe something that is infrared or ultraviolet? Because, for example, if you're on deeper depths, because the more blue light cannot really penetrate there, so you would have less noise, or the reds can penetrate more water, so you would have a greater range.
There's a lot of echo. I'm not sure I understood your question. But anyway, here we had to reach a certain appropriate trade-off between the cost. So we didn't go for very expensive units. Another big problem is that we had to take care of the influence of the light from the sun, because if you go for very sensitive modems and if you are not careful enough, then the thing will saturate. Now, the color that we choose, I mean, if you are interested, I can send you a paper, and this is a curve that is known to everybody, where we simply selected the best color according to whatever was published in some book. But I don't know if this was your question, because there's a lot of echo.
The question was related to exactly what you mentioned, the color. So why you do not use infrared or ultraviolet in a high depth water, for example? That was the question.
I can't answer that. That's not my specialty, but it's in the paper that is mentioned there. So I can send the paper. I don't know, if you don't mind sending me an email, I'll be glad to send you the paper where essentially we extract a figure from sub-book, and by following the guidelines, that's how we choose the frequency of emission. Okay?
Okay, thank you. Another question? Okay, thank you everybody for participation in this first session of the workshop. Now we have a coffee break for 15 minutes, then we continue at 11 o'clock. Tamara will chair the next session, and we will have a PhD presentation. Thank you very much. Coffee break is served outside at the lavender bar.
Antonio, Roberto, thank you for presentation. Bye, guys.
Thank you very much. What a pleasure.
Thanks. Take care. Good one.
Stay happy and safe. Bye-bye.
Will do. Thank you.
Bye, Roberto. Thank you very much.
Bye, Antonio. A pleasure as usual.
Thank you. Bye-bye.
Time for coffee on my side.
Okay, bye-bye. Bye-bye. Thank you very much.
Ne.
Što niko nije koristio onaj?
Klikni da klik.
To radi.
Ne radi. Aj, majko.
Ha, pa ne su ti čak čučali za
Svako sam napaca i sve pokušavam skratiti, ali... A nemaš 15 minuta. Amara rekla će vi i kako bude preko 15 minuta.